Welcome. Today I'm going to start the chapter that nuclear magnetic resonance NMR, or we can say that is nuclear magnetic resonance. Here the resonance means coupling, that will be coupled between two protons, or maybe between two carbon atoms, maybe between two fluorines. Okay, so that resonance means coupling. Here that nucleus word, this nuclear, this means that nucleus. So now what we say that we have studied that IR spectroscopy. Here what is to do that if the molecules have different functional groups, then on that case what we used to do, to characterize the different functional group, we use IR spectroscopy to characterize the functional groups. We use that IR spectroscopy. But if a molecules have that, if you want to characterize a molecules, if you want to characterize a molecules based on what type of atoms around a particular atoms, so on that case we are using that nuclear magnetic spectroscopy. So to characterize the structure of a molecule based on nuclei of atom. So if a molecules is there, let's say if we have the molecules, if this is a molecule, now you want to characterize these molecules by NMR. So let's say you have that proton NMR. Then what is to do that? Then what you say that in this carbons, if you write it something like this. So but in the 1H NMR, what we say that around these carbons, how many protons are there, and due to this proton, how many signals we are getting. So here we will not, this is not useful for functional group, but if you want to characterize the structure, how the structures look like, means around these carbons, these protons are there, and these protons are in different, or they are in the same. So that things if you want to characterize, likewise you can, if you want to uh, study the structure of a molecules, then we are using the 1H NMR, that we will discuss detail. Okay, so basically what I am going to talk in this part, first I will go on introductions, means some basic about of 1H, basic importance of NMR spectroscopy, general NMR spectroscopy. It may be 1H NMR, it may be 13C NMR, it may be fluorine NMR, it may be phosphorus NMR. Okay, so the basic introduction I will first talk. Next I will talk on uh, number of signals. I will talk on number of signals. Then I will talk on chemical shifts. Then I will talk on factors affecting chemical shifts, factors affecting this chemical shift. Then I will talk on splitting of signals, then I will talk on splitting of signals and coupling constants, J, and then I will discuss on factors affecting splitting of signals, then I will talk on some about of DBE and PYQ, previous year questions. So this will be the whole topics while I will go through. So first I will start on that is introductions. So whenever you say that nuclear magnetic resonance, that is 1 NMR, it means that is nuclear magnetic resonance. So here that what we will study, that here you say that resonance means coupling and nuclear means nucleus, okay, and magnetic means we are giving some magnetic movements and that molecules have some magnetic movement, and with that they will cancel with each others and they will give some magnetic values. Okay, so based on that signals will comes on that we will identify the, based on signals we will identify the what the structure should look like. Okay, so here that whole the concepts of one is this nuclear magnetic resonance is based on the nucleus. Okay, so now the which type of molecules, which type of atoms are nucleus active, which type of atoms are nucleus inactive, that is also you have to study. So thing is that let's say if we have that some molecules, some atoms is there, some atoms like D2 is there, and some atoms is there carbon 12, and some atoms is there carbon 13. So some atoms is there, let's say nitrogen. So all this case where that where we can use that NMR, where we can't use the NMR. So this NMR is based on the nucleus. So we, looking at nucleus, we say that whether this is this we will study in NMR or not. Okay, so that we will look. Let's say if it is deuterium 2, deuterium. So here that mass number is 2. Here mass number is 12. So what we see that we may notice that carbon 12 that NMR is inactive, whereas carbon 13 is NMR active, and carbon 14 is also NMR inactive. Okay, this is active, and this is also NMR active. Okay, so these things we see that these are active, these are inactive. So based on which, this is based on the nucleus. Okay, so how we say that conditions for nuclear active, nucleus active. So there is basically the two conditions. One is the charge and other is that is spin. One is charge, another is spin. Let's say this charge, if you talk about a charge, so if any molecules, let's say it is the nucleus, and here that electrons are revolving around a nucleus, then what we see that this nucleus has neutron plus proton, and this nucleus is, this is positively charged, and this electrons, let's say electron is revolving around the nucleus, and this electrons has negatively charged. Then what we see that if you give that any energy to these atoms, then this nucleus can be removed. This nucleus we can remove from the atoms. Okay, but this if you give how much energy also, we can't remove the proton. So it means that that atoms is always positively charged, because this nucleus we can remove by giving the energy, but that protons we can't remove. So this nucleus is always positive charge. It is always positive charge. How much energy if you give, then also this remain as a positive charge. So based on that charge, we can't distinguish that what type of nucleus it is. Okay, so next condition is that is spin. Next condition is on spin. So this spin is, this is a nuclear spin, and it is represented by I. Okay, so this I, what you say that here I is equal to 0 or I not equal to 0 and I equal to 0. So if that nuclear spin of I, nuclear spin, that is 0, and other case that is not equal to 0. If that nuclear spin that I is equal to 0, on that case what we see that this is NMR active. And if it is equal to 0, if that spin, how we calculate I, that I will discuss, but we see, but first we will look that if I is equal to 0, then we see that that is NMR inactive. It means that we can distinguish that nucleus of an atoms by nuclear spins. If I is equal to 0, then that is inactive, and if it is not equal to 0, then that is NMR active. Okay, so this is the first thing, that we look that I is 0 or not. Okay, so if I is 0, then that is inactive. On that case, we can't study for that type of atoms whether it is we can't study that type of atoms in NMR. Okay, so here that if wherever that I is 0, we can't study, because we get that is inactive. NMR is inactive in this case, so we can't study NMR. Okay, only for active we will study, that is for I not equal to 0, only here we study that we can study NMR. Now the question is where that I is equal to 0 and where I is not equal to 0. So for that, what we see, here, if now we know that there is a mass, so nuclear, whenever in atoms, where suppose this is an atoms, that we have that atomic number X and we have that mass number. For any atoms A, we have that atomic number Z and mass number, let's say n. Okay, so in this case, what we say that here that any atoms, if any atom the mass number is not divisible by 4, then it is I not equal to 0. So what you look that if that I, if that mass number, you look that mass number is divisible by 4 or not. If it is not divisible, on that case I is not equal to 0, and that is NMR active. Okay, so we will look that that mass number. So here that any atoms, we are looking for any atoms. On that case, you know that mass number we will divided by 4. If that is divisible, completely divisible by 4, then that is NMR inactive. And if it is not divisible by 4, then on that case that is NMR active. Okay, so here we say that if mass number of an atom is divisible by 4, then I equal to 0, that is NMR inactive. Okay, so what we will look that we will just divided by 4 of that atom mass number. That mass numbers divided by 4, that is 4. Always you divide by 4. Okay, if it is divisible by 4, then that is inactive, and if it is not divisible by 4, then that is active. Let's say you have the examples. Examples like we have 1H, that is hydrogen. Here that mass number is also 1, so divided by 1 upon 4. So this is not divisible. Okay, so this is NMR active. Let's say you have that carbon 12. So here that mass number is 12, and we will always divide by 4. If it is completely divisible, then this is NMR inactive. This is NMR inactive. Okay, similarly this is NMR active. Similarly, if we have that carbon 13, then this 13 upon 4, that is not divisible. So this is again NMR inactive. Sorry, NMR active. Okay, so what we will look that we divide by 4 if that mass number of an atoms is divisible by 4, then that is NMR inactive, and if it is not divisible by 4, then that is NMR active. Okay, so this way we can distinguish that whether this particular atom is NMR active or not, whether we can study the NMR or not. Okay, that is I equal to 0, I not equal to 0, and that will be done by dividing by 4. So now we understand that where that we will study NMR, that where we can't study the NMR. For that, just divided by 4. If that is divisible, then that is on that case we can't study NMR data. If it is not dividing by 4, then on that case we will study the NMR data. That is NMR active nuclei. Okay. So here we say that NMR active nuclei and NMR inactive nuclei. So which are NMR active nuclei? So that is, we can say 1H and deuterium, and all which are not divisible by 4. So here simply write not mass number of atom not divisible by 4. Here inactive, mass number of atom divisible by 4. Okay, so if you take that examples, then we can say that 1H, D2, any atoms which is not divisible, that mass number is not divisible by 4, like any atoms you can take which is not divisible by 4. Okay, and that is divisible by 4, like you can say that carbon 12 and oxygen 16. Okay, these things which is here 16, that is divided by 4, then we can easily divide by 4. So this is also NMR inactive. Okay, so this way we can say that which NMR, for which case we can study NMR, or for which case we can't study the NMR. Now moving to the next points, that is, let's say if the molecules have the NMR active. NMR active nuclei. So NMR active nuclei are what are, that is not divisible by 4. So that is deuterium also not divisible by 4, and 1H and 1H, this is also H1, this is also not divisible by 4, and carbon 13 is also not divisible by 4, and if it is nitrogen, this is also not divisible by 4. So on that case we say that we can study the NMR. But what we see that NMR, what we found, that is general NMR we found, that is we say that 1H NMR we get in lab. We have 1H NMR, we have that 13C NMR, we have that chlorine NMR, and we have that phosphorus NMR. But we don't have that NMR like deuterium NMR. You don't have that NMR like nitrogen NMR. So why? What is the reasons behind that? We only get this type of NMR in lab, but we don't have that NMR like that is nitrogen 14 NMR, deuterium NMR, and that NMRs like nitrogen, oxygen, any NMRs. This type of NMRs we will not get, only this type of NMRs we have. Why? What is the reasons behind it? So the reason is, what for it the nuclei, so we will classify two types. First is that is nuclear active. Okay, so this nuclear active, that is also divided by two cases. That is that so here talking based on that that is spin. Okay, so what we say that if I, so this is I not equal to 0, on that case that is nuclear active. Now this I is equal to half, and this I is not equal to half. I mean I may be 1, maybe 3/2, maybe some value, but that is not equal to half. So this way we can distinguish, we can divide that nuclear active protons, nuclear active atoms in two categories. One is I, that I is this spin may be equal to half, maybe and then on the other case that is not equal to half. So this we can say that this is non-quadruple, or we can say this is spherical, and this is quadruple, or we can say this is non-spherical. So what we see that here like if we have that I equal to half, where this I is equal to half, that is the case. Like if you see, if you calculate that I of 1H NMR, then we get that for this case I is equal to half. And like we have that carbon 13, here also I is equal to half. And like you have that fluorine 19, here also I is equal to half. And also we have that case of this, here also I is equal to half. Okay, so what we found that where I is equal to half, or on that case means that type of NMRs we have. And where if we have that I is not equal to half, on that case that type of NMR we don't have. The reason is, whenever this I is equal to half, then what we found that here that signals, you will get that one signals, means signals we have here is that type of signals we have. Okay, and whenever this I is not equal to half, sorry, I is not equal to half, on that case what you see that the signals, if you look, then that signals is something like this broad signals you will get, broad signals. And wherever this, then we have that when I is equal to half, on that case what you see that sharp signals. And here we have that broad signals. And we know that if it is a broad signals, then is it so in this value, this amount of some signals values are there, so multiple values you will get. Okay, here that multiple values you will get. And if it is a sharp signals, then you will get that single signals you will get. Okay, so now you tell me that which NMR, which spectra is good to study. If you are getting that broad means multiple signals, then how can you characterize, how can you distinguish that what type of peak it is? And if it is sharp signals, then we can say that this signal is for this value, so we can easily characterize the structure of the molecules. That's why that what we say that whenever this I is equal to half, on that case we get that sharp signals, and that type of NMRs we have, that is this 1H NMR, 13C NMR, and chlorine NMR, and this phosphorus NMRs. Okay, and whenever this I is not equal to half, I may be any value other than half, on that case we are getting that non-spherical, and that signals we are getting, that is the broad signals. So this is not useful, that's why we will not get this type of NMRs in the labs or in any industries. Okay, so now the questions will come that where this I will be half, on which case this I value will be half. Okay, so now how to say that this I is half for this case and I is not equal to half this case. So there is a simple trick for this. What you say that if mass number of an atom is odd, then the I is equal to half. So what you say that everything we are studying on the basis of mass. Okay, if mass number of an atom is odd, on that case I is equal to half. Okay, so like if we have this is odd number, this is odd number, this is odd number, this is odd number. So whenever if I is equal to half, if the mass number of an atom is odd, on that case we getting that I is equal to half. And if mass number of an atom is even, then I is not equal to half. Okay, so based on that mass number, if it is odd, then on that case we are getting the sharp signals, and that is I equal to half, and that type of NMRs we have, and this type of NMRs we don't have. Okay, so what you say that, so if I give that, what you say that according to nucleus, what you are looking at, mass number we will look, and this mass number also for that NMR, what that this mass number not divisible by 4 and not divisible by 4 and mass number is odd. On that case only we are studying that NMR data. Okay, and if it is not divisible by 4, then we not study NMR. Okay, so for studying that NMR of an molecules of an atoms, what we look, that first point is that is divisible by 4 or not, that mass number, and secondly that is odd or not. Okay, so these 2 points are needed to study that structure of an atoms. That is, first is mass number, and that another is mass number not divisible by 4, and second is that mass number has to be odd. Okay, so these are the 2 points to study if you want to study of a data of NMR data. If it is divisible, if it is not divisible by 4, and but it is a even number, there also we will not study that NMR data, because on that case we are getting the broad peak. Okay, so these are the some basic introductions for all the NMRs. So this is applicable for all NMRs, whether it may be 13 NMR, whether it may be 30, whether it may be 13C NMR, whether it may be 1H protein NMR, whether it may be chlorine NMR, whether it may be phosphorus NMR. Okay. So now next, let's move to that splitting, or that is number of signals. Okay, so that we will discuss in the next class. Today, up to this, thank you.